In this video, I just wanted to show you a couple of examples of how we use completing the square to write quadratics in vertex form. So given a standard form function and we want to get it into vertex form, we can use the method of completing the square. But keep in mind, we're not solving, we're just trying to rewrite it in vertex form. So let me show you a few of these. So for example 1, I have y equals x squared minus 8x plus 11. So for the first step, we're going to write y equals x squared minus 8x plus the blank like we use when we're solving by completing the square. I still have 11. I'm going to add this c value that we find when we complete the square, and then I'm also going to subtract the same amount because you have to keep an equation equal. So I can't just add something, but I can add it and subtract it. That's equal to what I started with. So let's continue. Remember, we take half of the middle term and square it. So half of negative 8 would be negative 4 squared would equal 16. And then we just have to write this a little bit cleaner and we'll have vertex form. So I'm going to write y equals, and then remember how with completing the square that this is equal to x minus half of b squared. And then we just combine like terms right here. So minus 5. So notice I go in one step using completing the square to put this into vertex form from standard form. All right, let's try another one. So here I'm going to rewrite y equals, then using completing the square, we're going to make this a perfect square trinomial is what we're doing. So then it still has minus 7, and we have to subtract what we've added, so really we didn't add anything, but we're just changing the look of everything. So x squared plus 2x, half of 2 is 1, and 1 squared is just 1. So we're going to add 1 and subtract 1, so that's why this is okay. Now I can write it in vertex form. So y equals, remember this is now a perfect square trinomial, so it factors into x plus 1, x plus 1. So we write x plus 1 squared. Negative 7 minus 1 is negative 8. And see, in one good step, we've got vertex form, and that is very helpful. Sometimes standard form is helpful, but a lot of times we like vertex form. Remember, from here, we can just pick out the vertex. So our vertex here would be negative 1, negative 8. Remember, the axis of symmetry comes from the vertex, so that's x equals negative 1. So it's a very useful form where we can get lots of things and graph it easily. All right, let's look at one more. What if a is not equal to 1? What do you do then? So here in this example, I put a is equal to 2 for an example of this. So you could take 2, you've got to take that out first. Then set up x squared minus 3x, because 2 times negative 3 would equal negative 6, plus blank. You still have the 12. Now, I didn't mean to write equals 0 right there. Let's take that away. We just need y equals. We can't have two equal signs. My mistake. So we need to put plus 12. And then we need to subtract this blank. But in this case, it's 2 times this number that we're going to need to subtract because that's technically what we're adding. So minus 2 times the blank will help us to subtract the equivalent of what we have added. So half of negative 3 is 3 over 2, or negative 3 over 2. And then when we square that, we get 9 over 4. So 2 times 9 over 4 is what we're going to take away. So let's rewrite the first part. We're going to write it in vertex form. So 2x minus 3 halves, because half of b always goes there. And then we just need to clean this up. So we have negative 2 times 9 over 4. That would reduce to be 12 minus 9 over 2, which is the same thing as 24 over 2, which is equal to 12, minus 9 over 2 would leave us with 15 over 2. So let's put 15 over 2. So that one just had some fractions involved, but that can happen sometimes. And so now we can pick out our vertex, which would be 3 halves and 15 halves. or 1.5 and 7.5 if we wrote it as a decimal. But I run out of room right there. So it shows you a very quick and easy way we can use completing the square to write standard form of a quadratic equation into vertex form.